Welcome people to my new video. Apologize for my bad English. In this video I will talk about do bad levels matter, and I will do a one-way ANOVA tests. First, some initial thoughts. ANOVA is short for analysis of variance. So analysis of variance, ANOVA. It's a one-way ANOVA, so it means it's a one-factor model. One factor, one thing, one entity will change. In my case, in this video, it's the bad levels system. I'm not going to explain in detail, what ANOVA is, when to use it, what are the assumptions and so on. I immediately will do the statistical test. So let's look at the Excel table. Here there are three columns. Here, 3 columns, 3 groups, 3 factors, 3 treatments, with 10 observations each. So there are 10 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So there will be 30 observations in total, 30 cells here, right? In total, 3 multiplied by 10. Now, one observation here, one observation is the end result, or will be the end result of a specific bad level system applied to a random roulette session. So 100 spins, called 38% red. So let's not complicate things, without zeros, so there will be 38 reds, 62 blacks, so 38 plus 62 is 100, 100 spins, a sample of 100 spins. Now, why it's random? It's still in some kind of order, so the dealer will not throw 38 reds and then 62 blacks. So the 38 reds and 62 blacks still will fall in some kind of order. So because there are 10 observations, there will be 10 orders. And that's what you see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 observations, and so 100 spins. 100 spins. And so that was the Excel table, I remember, without the data, and so with data. So the default here is loss in euro. So if you see 24, it means I've lost 24 euro. When you see 528, it means I've lost 528 euro. 262, I've lost 262 euro. And so that's what you see here, right here, with Oscar Grint at the end. And my loss was 528. 262 and so on. Now remember, the whole point about the video was, do bad levels matter? But with regard to what? With regard to your fun, to your time, to the beauty of the roulette dealer. It's to loss in euro, mu. So the null hypothesis says or claims mu1 equals mu2 equals mu3. And I put it in green because the null hypothesis is some kind of, starting point. We assume this to be true. It doesn't mean it is true, and we need to test it. So that's the alternative hypothesis. That's when the null hypothesis is not correct, is not true. Here you can see null hypothesis is a form of hypothesis that is deemed true until proven wrong based on experimental data. Now be very careful, you will say now, but that's too bad, this is not the same level as this. But wait, not too fast. When you take samples from populations, it's normal to get some variation. It's normal to get some variance. We really need to test it. So let's do the ANOVA test. So here is I did the ANOVA test, the one-way ANOVA test. Source of variations between groups, within groups, so the variation within groups, and then the total. So this is the sum squares, sum of squares between groups, is this, sum of squares within groups, and then sum of squares total. This is the degrees of freedom, so this divided by the degrees of freedom is the mean square between groups and the mean square within groups. This is some kind of reference, so that's why we divide this by this and we get the F value from our data, 39.5. Now the F critical value is 5.488. Why? So how do I get this? Well, I took, significance level of alpha 1% and the F2 27 distribution, like here, right? 227 distribution, right? So 2, and now we need to look at 27, right? So that's here, and here you see 5.488. You do one-way ANOVA test. You see the F critical value. Here, that's this blue here. The F critical value is 5.488, and it creates this rejection region. And so our F value from our data is greater than 5.488. It's in the rejection region. So we need to reject the null hypothesis. The null hypothesis is not true. We assumed the null hypothesis to be true. But now we come to the conclusion it's not true. We need to reject the null hypothesis and accept the alternative hypothesis. We are not done. Now we need to do 3 times a t-test. So one time, this first t-test is between the flatbed and Oscar Grint, the second t-test between flatbed and D'Alembert, and the third t-test needs to compare Oscar Grint to D'Alembert. And again, the same null hypothesis. We assume there's no significant difference, and that's this 0 here, between the flatbed and an Oscar Grint. We assume there's no significant difference between flatbed D'Alembert and no significant difference between an Oscar Grint and an D'Alembert. But I did this, okay, here are the results for the first t-test. 313 is higher than 137, so it's again in the rejection region. So that's why it's now red. It's not true that there is no significant difference, because there is a significant difference between a flatbed and Oscar Grint. The second t-test, 260.8, is higher, greater than 59.78, right? So again, it's not true that there is no significant difference between a flatbed and a D'Alembert, because there is a significant difference. Here, the third t-test, 52.20, is not greater than 150.19. It's not in the rejection region. We cannot reject the null hypothesis. So it is true that there is no significant difference between Oscar Grint and D'Alembert. So that's why gambling is so complicated. It's always different.